So in the last video, I made a handful of scans. I think it was 5 in total. And each of those scans, I made sure to scan enough overlapping data. So in between the different scans of with the bumper on, with the bumper off, the back side of the bumper, I had enough data points, 3 major data points, on each of those that overlapped. So that way I could overlay them one on top of another within some margin. Uh, and the way that I go about doing that is using this program that I learned from Making for Motorsports. When he showed it, it was called GOM Inspect. And now they've renamed it, rebranded it. It's the same program, but just a new name. And you download it from the Zeiss Quality Suite. I'll put a link down below of where you can download it. But the program that you care about inside of that suite is called Inspect Optical 3D. It's the same thing as GOM Inspect, it's just the newer version with a new name. And so that's really helpful in taking your scan data, bringing it into a coordinate plane, so that way it's all oriented around the same point. And then you get to use point features at major components, major points on the component, and it overlays them, gets them as close as possible within some margin that you get to play with. So I'll show you how that workflow goes because it's free. And as Making for Motorsport said, it's free. And that, is nice when you're trying to do stuff on a budget. So it does limit you a little bit in your capabilities. So I'll show you how I get around that. So once you launch your Zeiss Quality Suite, you're going to want to go to your All Applications, find yourself to the Inspect Optical 3D, and yours will probably say download or install it, and then go ahead and press start and or launch, and that'll bring it up. Once you get launched into your Zeiss Inspect, you're going to go ahead and open up a new project. So once we're into the Zeiss Inspect or GOM Inspect, it's a pretty simple program. I haven't dove too deep into it, but the field that we're going to be paying the most attention to is the center, the upper right portion over here, and that's how you do your alignments. And then the left is how you control your models, your solids, and your meshes. And I'll explain more on that in a minute. So if you're not like me, where I've already either gone through and done it, or I have previous models of the focus that I've already oriented to the coordinate plane, what we're going to want to do is do a 3-2-1 alignment, I believe. So I'm going to pull up a file. I like to use scans for things that came off the scanner, and then a GOM file for things that I've already oriented. Just keeps it clean. So I'm going to pull up the scan. Let's just go with the stock bumper, drag and drop, and I'm going to select new part. And I'm going to select this as a mesh. So now, as you can see, this point here is my origin. And the origin is my green being Y, red being X. I want the body to be oriented somewhere reasonable around here. So I'm going to come up here to my original alignment, and I'm going to do a 3-2-1 alignment. So a 3-2-1, you pick 3 points that are on a plane, 2 points that make up a line, and 1 point that makes up the final axis of just where you want the origin to lie. And so for the front bumper, we want to try to pick something that we know to be flat, and that is rather hard. So we're going to call the underbelly tray. I don't want to do that the flattest thing. The intercooler is probably the flattest thing, so we're going to go with that. And so we are going to press Control. We're going to pick 3 points to determine the plane. Boom, boom, boom. Now we're on to our Z. And we want something that's vertical. So let's select these 2 points. And then our Y. I'll take that. So now as you can see, Z goes from left to right and X goes front to back. Now X I'm okay with, but Z I want to be up and down. So we can come over here to our rule and we can change that until it fits the orientation we want. So that's all well and good, but Z is going the wrong direction. So can we do the plane positive? Nope. Line positive. There we go. And so now you can see that this point here is going to be the origin for the model. So now with that, we're going to be done and our alignment to the origin is okay. Now if you want to change this later on and move the origin like down to the center of the car, it's easy to do from here because the model is now oriented and roughly square with the origin. Now, it is okay to get frustrated, and sometimes I redo that initial 3-2-1 alignment several times. It is not super intuitive, and sometimes if you're trying to use like the intercooler like I did, you could be clicking on a divot inside the intercooler, so then your plane gets all skewed. So it's really important to have good, clean areas to do these sorts of alignments. So now that I have that alignment done, I'm going to roll into how I go about exporting that initial alignment and how I take the next steps of aligning the next scan to that one. So now that we have our mesh, it's important that it's a mesh aligned to our new origin point. You're going to come over here to the left-hand side where it says part. You're going to highlight mesh, just one left click on it. Come up to File, Export, Mesh, STL. Now this is where I would come in here and go stock bumper, but I like to put GOM in front of it so I know that I've modified the origin. And then you go through and you pick the folder location wherever you want it to be and you press OK. So now we have our initial scan. It's oriented to the global position, the coordinate system, and now each successive scan we're going to pull in and align to this model. That way everything will eventually look like this and overlay with one another, which will help like tenfold down the line when we get to doing complex designing and fitting stuff in here. So now let's work on pulling in the rest of them. So now we have that first scan aligned, we're going to go in and pull it back in, but as a CAD body this time. It's really important for doing the alignments from a mesh to a CAD body. As far as I know, you can't do a mesh to a mesh. So I've cleared the files that we had loaded. Open up our file explorer. And I've already gone through and done all of them, but I'm going to re-go through one of them so that way you guys can see. So we had the stock under bumper. I'm going to load this in as a new part. It's really important that you switch from a mesh to a CAD body. And press OK. Now that it's loaded in, you are probably noticing that the coordinate system changed, but that's just because I already modified it so that way it's where I want it. But the big thing is getting it aligned and coplanar with the flat points or the bottom of the car, at least in this case. But so now that we have our CAD body loaded, we can see it up here. Now we want to go ahead and pull in our mesh. So go back to our files. We're going to go to our scans because we haven't pulled them in yet. And let's just say I'm going to align the front bumper. So you can't do a new part again because you didn't pay for it if you're like me. And you're going to go click on Add to Part. Now here, you do have to bounce back and forth between CAD body and mesh, but we're going to click on mesh for whatever file we bring in. I'm going to press OK. Now you can see that the file that we already oriented is where we want it, but this guy's way off in space. So now we're going to have to align this down to here. And if you see, I purposely scanned the front quarters, at least a portion of it, because they're on both sides of the scan. And we'll use that to our advantage. So now we'll come up to original alignment, click on the plus. Sometimes pre-alignment works and surprises you. Let's give it a try. It's got to think for a minute and it didn't like it. So we'll come back up. We'll do a 3-point alignment. And so what this does is you select 3 points on your CAD model and 3 points on the mesh model that are really close to one another. So like I'm going to zoom in on both of the driver's side quarters, and I'm going to press Control, click on that point, and then do the same thing over here. So those 2 points are really close, within some margin, right? And now I'm actually just going to pick another point over here. We're going to go there and there. So it's got those 2 points. I'm going to swing around to the other side of the car. And I'm going to select kind of the same point here and here. And as soon as I press go or click on this one, it's going to jump. There it goes. So now you can see that it's really close. And this is just the initial alignment. So we'll go ahead and press OK. And I'd probably call this OK and just stop here. But if you say it's a little off and you want it to be more, so now we go into like the secondary alignment or whatever it's called. And usually the local best fit by nominal elements works really well. Click on that and it just gets it that much closer to lining up. So you should see like your meshes kind of overlap and struggle to separate the two. And then don't forget to press OK. Sometimes it doesn't line up so well and you got to mess with the maximum distance. That's saying that it will move the model that amount to try to overlay them. So if it's really small and it say it had to move like 10 millimeters to overlay the models appropriately, it won't do that. So sometimes messing around with this gets you a better result. We just press OK. So now again, just like we exported the first one, we come over here to our file tree. We're going to just left click and highlight the front bumper mesh. Come up to File, Export, Mesh, STL. And then same thing here. I would come up here and label it the GOM front bumper STL. And then I'd press OK and export it to my file. And then from there, it's pretty much just rinse and repeat the last like 2 minutes of me talking to get all of your files oriented in this configuration. All right, so as to not make this video solely about how to use GOM Inspect and kind of get into the next development stages of proceeding with this design, we're gonna go, I'll pull up Amazon, I found a light bar, I watched a handful of reviews on it, it's cheap, it looks halfway decent, it's probably the one I'm gonna use, and we're gonna get into CADing that based off of the dimensions on Amazon, so we don't have to buy it yet, and we can just kind of figure it out, but pretty soon we'll be buying it. And then I have a couple other components, like little servos that I think I want to use, and we'll just get those located in space and see what we can do for packaging and if it's possible. I'm fairly confident it's possible based off of how much room we have back there and all the measurements I've been taking. But let's get into doing a little bit of CAD of just some rough design, making a big block that's going to represent the light bar, the servo we're going to use, and then get it into the CAD model and see what we can do for positioning. So I'm going to try to do a time lapse of this, and I'm just going to quickly be going through and quickly CADing up the light bar that I plan to use, and I'll put the dimensions on the screen as I do it, down in the corner somewhere that it's probably hard to see. But I'll put it there, and I'm probably, mostly done with doing the CAD by this point. But I'm gonna get into it, and you can finish up watching the time lapse. So I know a lot of my sketches were not fully defined. Sue me. This purpose is really just to get an idea, and I'll probably end up ordering the light bar this weekend and getting the actual one in, and then I'll measure it. Maybe I'll even scan it just so I have the 1-to-1. I'll probably just gonna modify this rough CAD to have a physical representation of what I want. But now we got that done. I have these little RC car servos. They're all metal. They say they're good to 35 kilograms, which I think is a lot for what I need this to do. And they're gonna be really easy to control with an Arduino. So I'm gonna get into doing a little bit of measuring with my calipers. Yes, I still use vernier calipers. They never break, the dial never runs out, it always works. But I'm gonna get into measuring these, and then we'll get to playing with it in space. Okay, so now we have the light bar CAD'd, the servos that I plan to use for actuating the door CAD'd, and we have our scan. So we're gonna pull all that together, wrap out this video just kind of playing around with it in space and seeing what's doable if we have to make any changes. I'm really hoping we can fit the double row light bar, just, more bulbs, more light kind of thing. But worst comes to worst, we drop down to a single row, thinner light bar if needed. So first things first, I've got my model pulled up that has all of the different levels that we've scanned. And now that I have it in space, I can go ahead and hide layers one at a time and see what's available for room. So originally I came to do the 20-inch light bar because I just measured roughly from here to here. And I can see it's about 23. And if I go from like the narrower point here to here, I get 20.5. So a light bar that's roughly 20 inches long should be able to fit in this space. And then also going from top to bottom, we've got roughly 3.5, 3 3/4 inches to play with. The next one, we can do the analysis and we can see the side. If you remember in the last video, this bulbous, I assume it's just in case like a ball or something hits the front of the car, the front end of your car doesn't cave in. So we're gonna yoink that out and we'll be putting a light bar behind here. So we'll probably do some sort of reinforcing in and around here in order to, in case something hits the front, it doesn't just crumple in instantly. So we're just left with the raw bumper where we plan to mount the light bar, and then we'll toggle this guy on and off to figure out where we want it. So insert a component, components, start with the light bar. So now you can see that the component goes to the origin point, and now we're gonna have to move it to wherever we want it. There's tons of different ways to move stuff in space in CAD. Sometimes, like for this situation, I'm just gonna move it around by using the sliders and whatnot and positioning it. So that looks pretty good, left and right. Maybe a scotch that way. So that looks pretty good. Now we can take the light bar and just whoop. Now it's disappeared behind the bumper. We can toggle our analysis. And we can see that we have tons of room for this light bar to sit. It can come all the way back here. Ideally, we get it as far forward as we can, but we have to have room for the door to open. So realistically, we're gonna tuck this down as low and as far back so that way the door can open up top. But pretty cool that it fits. So like that, hide the analysis, and then we can toggle the front bumper off and see that you just have this big light bar right in the center. Now let's go ahead and insert our servo. Let's see what the back side. So this is the back side of the bumper. So I can see that it's kind of hitting in places on the back side. We'll check the analysis. So we will definitely have to move this as far back as we can if we want to use this light bar. So from what I'm seeing, we're probably going to be dropping down to a single DIN or a single row light bar, but I think that'll be okay. We might try to make this work. The light bar roughly fits. It might be a little bit too big, so we might be dropping down to the single row light bar. And then as far as the servos go, I think I plan to do one at either end if I do a full single length light bar, just because of the torque. There's gonna be tons of torque, but it'd be nice if it just gets driven from both sides. So that way, whatever 3D printed bar doesn't have to have some crazy reinforcing going from end to end. But maybe that's where we end up anyways. For now, I want to put a servo at each end if I do a full length bar. And I don't know if I'll put an arm that mounts to the door and pulls the door around an external pivot, or if I'll put the servo straight through a bearing set that's where the door pivots, and it will rotate the door at the pivot point. Those are the two kind of ones that are floating around in my mind right now. And I'm also open to doing two separate light bars that are like 7 inches apiece. I'd appreciate the feedback. Let me know down in the comments below what you think. Should I do a single large light bar or 2 smaller light bars? And then what do you think? Do you think the servo would be better to go through the pivotal axis for the door, or do you think it'd be better to have the servo with a lever arm that grabs the door externally to the pivot? Thanks for hanging around. I'll see you in the next one.